In this question we are given that there is a researcher who plans to identify each participant in a certain medical experiment, and it has to be done with a code which should be of either a single letter or a pair of distinct letters written in alphabetical order. So this is the constraint that we have to keep in mind. So it should be either a single letter or it should be a pair arranged in alphabetical order. We have to find what is the least number of letters that can be used if there are 12 participants and each participant is to receive a different code. So at the minimum, the number of possible code combinations should be greater than 12. Now before directly understanding this question, let's take two numbers, two alphabets, and understand what the question is actually trying to ask. So suppose numbers here A and B. Now the total number of ways in which I can select a single digit will be equal to 2. So the number of ways in which I can select these letters individually will be equal to 2. Let's just write this here. And if I arrange this, this will be equal to AB or BA. But we have to take those pairs of distinct letters which are written in alphabetical order. So we know that it will be only 1. So pairs will be equal to 1 and we can write this as 2C2. Then the total such combination will be equal to 2 plus 1, which is 3. Now let's take three letters A, B and C. So when we arrange this, we get AB, AC, BC, and we also get CA, CB and BA. Now if we have to select these letters individually, then the number of ways in which I can select these as a single letter will be equal to 3. And if I have to select these as pairs arranged in alphabetical order, we see that this is possible in only 3 cases. So this is equal to 3C2. This gives us a total value of 3 plus 3, which is equal to 6. Similarly, let's take 4 letters. Then the number of ways I can select the letters individually will be equal to 4, and in pairs arranged in alphabetical order will be 4C2. Then the total number of ways or the total codes that I can get is 4 plus 4C2. Now this is equal to 4 plus 6, which is equal to 10. Now 10 is still less than 12, so we have to check for 5 letters as well. Now if there are 5 letters or the 5, then the number of ways in which I can select these letters individually will be equal to 5. And in pairs such that they are written in alphabetical order will be equal to 5C2. So when we find the total, this should be equal to 5 plus 5C2 is 5 times 4 times 3 times 2 times 1 divided by 2 factorial times 3 factorial. Now 3 factorial and this gets cancelled and 2 cancels 4 2 times. So we get 5 plus 10, which is equal to 15. Now this is greater than 12. So we can say that the minimum number of letters that we need to get such a different code will be equal to 5. So the correct answer is option B.